Find the area between y equals to x plus 1 times x minus 2 times x minus 3 and the x-axis. X-axis means y equals to 0, so I have a purple line on the x-axis. The area between these two functions. So the y equals to x plus 1, if you multiply all of this, you will get a third degree polynomial, and then this is the graph of the third degree polynomial. There is a y-intercept at x equals to -1, x equals to 2, and x equals to 3. But take a look at the area. So in the region number 1, we have the polynomial on top, the y equals to 0 on the bottom. But when you take a look at 2 to 3, now the x-axis is on top and then the polynomial is on the bottom. So we have to do two definite integrals. So for the first definite integral, we will have to find this. So we will have to do definite integral from -1 to 2, and then the top curve minus the bottom curve. Why do we use the top curve minus the bottom curve? You have to check out one of the video I taught previously. So on my channel, I have one video, just very clear. I give you a very clear explanation about why do we use the top curve minus the bottom curve. Just look for it. It's on my channel. One video I gave a clear explanation regarding why do we use the top curve minus the bottom curve. Okay, the top curve is the third degree, right? So we have x to the third minus 4x squared, and then plus x plus 6, and then minus 0, and then a dx. Now you might ask me, hey, minus 0 is nothing. No, I disagree with that. We will need this in the next integral. So this is the top curve minus the bottom curve. And then on my lecture notes, I usually state that this 0 means y equals to 0, which is the x-axis. I would like to make my notes crystal clear. Okay, so this is not a tough integral to deal with. So we can start integrate right now. So that is plus 1, and then 1 divided by that, 2 plus 1, 4 divided by that, and then this is 1 plus 1, 1 divided by that, and then 6x, right? And then x goes from -1 to 2, -1 to 2, and then you use the fundamental theorem of calculus, plug in the 2, plug in the 1, subtract them. So we have 1 over 4, 2 to the 4th, minus 4 over 3, 2 to the 3rd, and then plus 1/2, 2 squared, and then plus 6 times 2. So that is for the upper limit, and then subtract the lower limit. This is always a subtraction because that is what the fundamental theorem of calculus gives you. It's always a minus. 1 over 4th, -1 to the 4th, minus 4 over 3, -1 to the 3rd, plus 1/2, -1 squared, and then plus 6 times -1. Okay, this one usually when you do homeworks online, they will need an exact answer for you. That means you cannot use decimal. You cannot just, okay, let's plug all of this into our calculator and then get an approximation. Sometimes they do not accept approximation most of the time because they want to push you to do all the common denominators. Now, on my channel, I make a video that shows you how to use your graphing calculator, TI-84 Plus, to evaluate definite integral. You should go check it out. Just search a keyword, use TI-84 Plus to evaluate definite integral, or you can say evaluate definite integral using a graphing calculator. I provide extremely clear explanation. It is very easy to do. So this one, when I was working on my notes, I will just write everything out, and then I will just get the answer straight from my calculator. That is equals to 45 over 4. Or when you do this on your calculator, they will give you a decimal. You have to use another function on your calculator to convert the decimal to a fraction. How to do that, I also explained in that video. If you don't know or don't remember how to do that anymore, go check it out. So this is exactly equals to 1125. So this is the area number 1. This is the region number 1. I should not say area, I should say region number 1. Erase that, so this is region 1. And then how about region number 2? So region number 2, this time, the top curve is the x-axis, and then the bottom curve is the third-degree polynomial. So for number 2, I am going to follow the color code. So this is from 2 to 3. So look, this plays a very important role. So this is a top curve is equals to 0 minus the third-degree polynomial, x to the third minus 4x squared plus x plus 6, and then you have a dx. So this is a top curve, and then this is the bottom curve. And then what is that 0 about? This 0 is y equals to 0, the x-axis. I would like to make my notes clear. And then this is 2 to 3, and then you just have to deal with the negative, right? So negative x to the third plus 4x squared, and then minus x, and then minus 6 dx, and then you integrate. So that is equals to negative 1 over 4 x to the fourth plus 4 over 3 x to the third, and then minus 1/2 x squared minus 6x, such that x goes from 2 to 3. And then you will be taking the top curve minus apply the fundamental theorem of calculus. So plug in the 3, negative 1 over 4, 3 to the 4th power, and then plus 4 over 3, plug in the 3, and then to the 3rd power, minus 1/2, 3 squared, and then minus 6 times 3. This is only for the upper limit, and then a big minus sign, subtract the lower limit, negative 1 over 4, 2 to the 4th, plus 4 over 3, 2 to the 3rd, minus 1/2, 2 squared, minus 6 times 2. So let me double check really quick. 3, 2, 3, 2, 3, 2, 3, 2. All right. So this one, I will just use a calculator to go straight to the final answer. This one, the calculator will give you an approximation. The approximation is 0.583333, and then you can convert that to a fraction. The fraction is 7 over 12, so which is approximately equals to 0.5833. Again, if you do not remember how to do this on your calculator, to be honest, this will save you a lot of time from making a mistake and save you a lot of time from doing common denominator. So this one is region number 2. Okay, now you might say, okay, I found a problem. Region number 2 is below the x-axis, so therefore the area is supposed to be negative. But how come the area is positive? So that leads us to the next question. That question is why the area number 2, I should say right region number 2, is not negative. Why? Do you see what the reason is? Do you see this? I use the top curve minus the bottom curve. So here is why. Because we use y equals to 0 minus the third degree polynomial, minus the x to the third minus x. This is the third degree. Do you see that? This is the negative. The negative is here. Which is right over here. Do you see that? Right over here. Here is the negative. So since I already put a negative, of course the answer becomes positive. So if you erase the 0 and then erase the negative, this will become a negative. So I add a negative. This is not adding a negative. It's the top curve minus the bottom curve. The minus makes the region becomes positive. So the minus is where the negative is. So can I just take that as a negative positive? Of course, yes. So how about the total area, region 1 plus region 2? Should we use positive or should we use negative? The answer is we use positive. So here is the total. So the total is equals to region 1 plus region 2, which is equals to 45 over 4, and then plus 7 over 12. They will just consider everything positive. So that is equals to 71 over 6. And this is the final answer to this problem. All right. Alright, so that is the end of this video. If you like the way I explain calculus integrals, give me a thumbs up, a subscribe, and I will meet you all in the next video. Signing out.